All right, welcome back. Let's keep going through part 5 of Target 17 notes here. Now, it says in this problem, find sine, cosine, tangent of the acute angles. There are two of them. Angle F was one, but angle D is the second. Only one that's not acute is E, remember? And remember, we're not talking about E as far as setting up these relationships and these ratios because we just don't do that with the 90-degree angle. All right, so now we're going to work on D. We're going to find sine, cosine, tangent, but we're going to base everything off of an angle D this time. And I want you to see what happens. You'll notice in orange, and I've changed colors on purpose, right? If you look at angle F, we have written opposite, adjacent, and hypotenuse based on angle F. But now all of that's going to change when we base it off of the other angle. And here's what I mean. If I look at D, let's figure out opposite, right? And opposite is always across the shape. Well, if I go from opposite from D, it's actually the 4 side, which used to be the adjacent from F, but now it is the opposite. And then if we look at the side 3, that left side, that is now the connecting side to angle D. So it's no longer opposite, it is now the adjacent side. The only thing that stays the same is across from the 90 is always your hypotenuse, so the hypotenuse is still the hypotenuse. But opposite and adjacent flip when we go to a different angle. And so I want you to see what happens with a couple of the ratios here. So let's talk about the sine of angle D now. Remember, sine is so is sine equals opposite over hypotenuse. So opposite now is 4, and hypotenuse is still 5. So sine of D is 4 over 5. And take a look here. Cosine of F, sine of D, same ratio, both 4/5. And that always happens because you flip opposite and adjacent when you change angles. Now let's look at the cosine of D. Cosine is adjacent over hypotenuse. And so from D, adjacent is 3, hypotenuse is still 5, so this is 3 over 5. And once again, we've got the same fraction with a different trig function as we've changed our angle of reference. And then tangent, something happens as well. So let's talk tangent of D. Tangent is opposite over adjacent, TOA, right? So opposite is 4, adjacent is 3. And so this is 4 over 3. And what I want you to see with the tangent is that we're still working with the same sides, opposite and adjacent, but they've flipped now. And so that's why our fraction is flipped. Tangent of F was 3 over 4, but tangent of D is 4 over 3. So that fraction flipped when the opposite and the adjacent flipped as well. All right, now that's just recognizing these relationships. Let's start talking about using them with a calculator and solving some problems. First, I just want you to know that there are sine, cosine, tangent buttons on our calculator. And we always base them off of an angle degree measure. And so all we're going to do is get comfortable typing these trig functions into our calculator and seeing what we get. And so we just want to type sine of 30 into our calculator. I can't show you like one of our district calculators right now because I just don't have access to it on this screen, but I can show you a calculator like this. And so we want to be in degree mode, first of all. I think you can see my cursor here. On your calculator, you always want to be in what we call degree mode. There's degree or radian. We're going to do things based off of degrees. So DEG is degree for short. And so if we want to know what the sine of 30 is, we want to just type that into a calculator. And so you should be able to see a sine, cosine, tangent button on any calculator you're using, even an iPhone. And so if I want to know what the sine of 30 is, I'm going to hit the sin button, which stands for sine, and I'm going to type 30 into the parentheses and close that parenthesis. And when I hit equal, it gives me a decimal. And that decimal is what my fraction equals as a decimal, right? These sine, cosine, tangent buttons describe ratios based on angle measures. And so if we do the sine of an angle measure, basically what it's telling us is, remember, sine is opposite over hypotenuse. It's telling us that no matter what, in all triangles that have a 30-degree angle, the sine of that 30-degree angle is going to be a fraction that reduces to 0.5. And so let's go back here and we will write 0.5. And it says use a calculator to approximate to 4 decimal places. So 0.5000. and there's 5. Now let's go check cosine of 18. Go back here, we can clear that. This time we'll hit the cosine button and we'll put 18 into the parentheses. Hit equal. That's 0.951, and if we round up, 1. 0.9511. And so we can write 0.9511. Now, I want you to get practice doing this, so do the other two on your calculator. When you type in tangent of 72 degrees, you should get 3.0777, and sine of 48 is going to equal 0.7431. So all we had to do in those problems is just use our calculator, type those things in. Remember to make sure you're in degree mode, and remember to close that parenthesis at the end of the trig function. We want that angle measure just inside the parentheses so it's linked to sine, cosine, or tangent, whatever function we're using. All right, now let's solve a few problems. So let's do this. Remember, we're going to solve problems using sine, cosine, or tangent. So I'm going to write TOA again. And the process is always like this. Pick an angle that's not the 90-degree angle, but it's one you know. And so we know the 63-degree angle. Then identify from there opposite, which is going to be y, hypotenuse across from my 90, and adjacent, which process of elimination is the x side. But remember, it's also the connecting side to that. And so if we want to find x, let's say we want to find x, we need to use x and then a number on the triangle we know, which is 12. Meaning we can't use x and y at the same time. We wouldn't be able to solve something with x and y. But we can solve something with only x. And so we have to make a ratio, which is a fraction, right? And so one of the parts of our fraction is going to have an x in it. The other part will have a 12 in it. And we still have to use this 63 degree as well. And so here's the idea. If we need to use x and 12, that's adjacent and hypotenuse. So which trig function uses adjacent and hypotenuse? That's this one, right? Cosine is adjacent over hypotenuse. And so I'm going to write cosine of my angle. So I'm going to put 63 in the parentheses. And then that equals my fraction. And so that equals the a over h part. So adjacent is x and hypotenuse is 12. And so this is the setup. The cosine of 63 equals x divided by 12. And now I need to solve for x. So I need to get it out of this fraction. And if I have a number on the bottom of a fraction, I can get rid of that by multiplying both sides by that number. When I multiply the right side by 12, multiplying by 12 and the 12 in the bottom of a fraction just cancels each other out. And so that's going to give me x on the right side. And then on the left is this whole thing. I just want to write 12 times the cosine of 63. But then I want to take 12 times the cosine of 63 and type that into my calculator. And that's what x will equal. So we're going to go back to the calculator, and I need to type in 12 times cosine of 63. So I'm going to clear this, and I'm going to hit 12 times, and then cosine, and put 63 in the parentheses. When I hit equal, I get that answer. And it tells me it's 5.4, blah, blah, blah. We'll round it to 5.4. And so that means x has to be 5.4. That's how long it is. Now, we have to repeat this process and figure out y now. So I'm going to erase some of this stuff, make it a little bit more clear. And now let's find y. But the difference is, to find y, now we have to use the opposite side. We still need to use the 12 because it's information we know. So we'll still use the hypotenuse. But this time we'll only use opposite and hypotenuse. Now, opposite and hypotenuse is so, right? Sine is opposite over hypotenuse. So to figure out this one, I'm going to do the sine, and we base off our angle of 63 equals, and it's opposite over hypotenuse. So y over 12. And then we solve in the same way. Times by whatever is in the bottom of that fraction, 12's cancel. And so y is going to equal 12 times the sine of 63. Let's type 12 times the sine of 63 into our calculator now. I'll clear that, and 12 times the sine of 63. And when we hit enter, tells us 10.7, we'll say. Round up, y is 10.7. And there's our answer for y. And so we're going to repeat that process for every one of these problems. And so let's do it. In number 2, since there isn't a y, let's add one. Let's make this side y. And so let's identify our angle. Let's figure out opposite, hypotenuse, and then the connecting side is adjacent. And so now let's solve these things. So let's go for x first. X requires adjacent, and then the number we know is hypotenuse, so adjacent over hypotenuse. That's the part. So cosine of 37 equals adjacent over hypotenuse, so x over 14. And then we're going to times both sides by that bottom number. The 14's cancel, and so x just equals 14 times cosine of 33 or 37. Type that into your calculator, and you should get 11.2. All right, now let's find y. Y is on the opposite side, and our hypotenuse is still the number we know, 14. So now we'll use opposite and hypotenuse. Opposite and hypotenuse is the so part. So the sine of 37, so, equals opposite, which is y, over hypotenuse, which is 14. Times both sides by the bottom number. Both sides, remember. So these 14's cancel, and y is going to equal 14 times the sine of 37, which is 8.4. All right, I think we're starting to get the hang of this, but it does get trickier. So a lot of times it's a one-step problem once you set it up. You just multiply by the bottom number. But other times it's a two-step problem, and I think we'll see that here solving for x in problem number 3. So let's do it. Remember, identify our angle, so 37. Then let's figure out opposite, adjacent, and hypotenuse. Across is opposite. Across from the 90 is hypotenuse. And then connecting side, adjacent. All right, so let's solve for x first. So we know 18, that's on the opposite side. And we want x, which is the adjacent. So now we got to work with opposite and adjacent. That's TOA. Tangent equals opposite over adjacent. And so we'll do the tangent of 37, and that's going to equal opposite over adjacent. So 18 over x. Now this time we have an x in the bottom of a fraction, but we're not going to change the algebra. Algebra is logical. It works the same every time. And so we're still going to times by the bottom thing. It's just this time it's x. And so when I times by x, my two x's cancel on the right side. And so on the right, we just have 18 left over. But on the left, we have x times the tangent of 37. Now, obviously we need to solve for x, and we have not done that yet because x is not by itself. I just want to remind you that all these numbers, tangent, cosine, sine, whatever, they're just numbers, right? So we can multiply by them and divide by them all we want. And so at this point, we're actually going to divide by the tangent of 37. And the tangent of 37 cancels on the left side, giving us just x. And on the right is what we're going to want to type into our calculator. We want to do 18 divided by the tangent of 37 this time. So let's do that. 18, clear this, do 18, and this time divided by, and then tangent, and was it 37? Yep, 37. So tangent of 37. Close your parentheses, it equals, there it is, 23.9. 23.9. And so x equals 23.9. And we'll pick this back up